Since not all polynomials are factorable, we can use a rational root theorem to help us find all the rational roots. If the polynomial has integer coefficients, then every rational root of the polynomial equation can be written in the form of p over q, where p is the factor of the constant term and q is a factor of the leading coefficient. We can use a calculator to help us divide the polynomial using synthetic division to shorten the process to a quadratic. From there, we can use a quadratic formula. This brings us to the rational root theorem. Example 1 will be the factors of the constant. So we have p is equal to 6, and you got to find the factors, which are 6 plus or minus 6 plus or minus 3 plus or minus 2 plus or minus 1. Those are the factors. And then of course q, which is the leading coefficient, we have plus or minus 1. So the possible rational roots are p over q, which is 6, 3, 2, 1 over plus or minus 1. I mean plus or minus for each of them, okay? So now you just have to divide. So it's plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. These are the possible roots. Now I'm going to use synthetic division to check if, and I'm just guessing 3. I'm going to check if 3 is a possible root. So I have 1, negative 5, 4, 6. Bring down the 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 4 plus negative 6 is negative 2. 3 times negative 2 is negative 6. And that tells us that it's a factor, which in this case it's a root. So my first root is x equals 3. The equation that we have is x squared minus 2x minus 2 equals 0. As I told you before, we're going to use a quadratic formula to solve this. So we have x equals negative, well, we need to know a, b, and c. So I know that a is equal to 1. I know that b is equal to negative 2. I know c is equal to negative 2. So the quadratic formula is 2 plus or minus square root 2 squared is negative 2 squared minus 4 times 1 times negative 2 divided by 2 times 1, which gives us 2. So we have 2 plus or minus square root. Negative 2 squared gives you 4 plus 4, negative 4 times negative 2 gives us 8 divided by 2. So the roots are going to be 2 plus or minus square root of 12 divided by 2, and square root of 12 can be simplified, which is the same thing as saying square root of 4 times the square root of 3. Square root of 4 is 2. Square root of 3. So I'm running out of room, so I'm going to go ahead and move it just a bit. And so we have as our roots, x equals 2 plus or minus 2 square root of 3 over 2, and we know we divided by 2, so our roots are going to be 1 plus or minus 1 square root of 3. For us to find the roots for this polynomial, we got to first determine the possible roots. So this is P over Q. So P are the constants of, the factors of the constants. So plus or minus 4, plus or minus 2, plus or minus 1. And then our leading coefficient is 1, so it's plus or minus 1. So the possible roots are plus or minus 4, plus or minus 2, plus or minus 1, and that's it. So now what we're going to do is we're going to use synthetic division to check if it's a root. So I'm going to try 2. So I'm going to go ahead and I'm going to write the leading coefficient. So it's 1, 3, negative 3, negative 12, negative 4. So you bring down the 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 3 plus 10 gives you 7. 2 times 7 is 14. Negative 12 plus 14 is 2. 2 times 2 is 4. And our remainder is 0. So x equal 2 is a factor. Or x equal 2 is a root. So my first root is x equals 2. With that information, I'm going to try to find the second root, and I'm going to try negative 2. And I'm going to use the remaining coefficients here from the last synthetic division. So it's 1, 5, 7, 2. Bring down the 1. Negative 2 times 1 is negative 2. 3 plus negative 2 gives you 3. Negative 3 times 2 is negative 6. 7 plus negative 6 is 1. Negative 2 times 1 is negative 2. 2 minus 2 is 0. That tells you that x equals negative 2 is also a root. And we came up now with the new equation that is a quadratic, and we're able to factor that using, we're able to solve for x using the quadratic formula. X squared plus 3x plus 1 equals 0. And I know that a is going to be 1. I know that b is going to be 3. And I know that c is going to be 1. So I'm going to go ahead and I'm going to find the remaining 2 roots up here. Remaining 2 roots. And I'm using the quadratic formula. So I have x equals negative b. In this case, it's negative 3 plus or minus square root b squared, which is going to be 3 squared minus 4 times a, which is 1, times c, which is 1, divided by 2 times 1, which is just 2. Remember, I'm using the quadratic formula to find the remaining 2. So negative 3 plus or minus square root. 3 squared is 9, minus 4 times 1 is 4, divided by 2. So x equals negative 3 plus or minus square root of 5 over 2. And those are the remaining roots. The remaining roots is going to be x equals negative 3 plus or minus the square root of 5 over 2.